So we'll start off with our bell work. I'm going to do it right in your notes with you. Our first problem said 3 1/10 times y equals 9 3/10. And we want to get that y alone. Our goal is to get the y isolated. So we draw the line down the middle of our equation, which is our equal sign. And we know that 3 1/10 and y are multiplying because they're right next to each other. So the inverse operation of multiplication is division. So we're going to draw our division sign in. And what we want to get rid of is that 3 1/10. So we are going to divide both sides by 3 1/10. Everybody with me? Okay. When you divide any number by itself, you always get 1. So those two will cross off and you'll be left with y equals. And now you have a division problem. You could go over to this side and take 9.3 or 9 3/10 divided by 3 1/10. And remember, when you do decimals, you are moving the decimal to make a whole number in the divisor, and what you do to the outside, you must do to the inside, so then you can pull your decimal straight up. 31 actually goes into 93 3 times, which equals 93, and you're left with 0. So in this case, y will equal 3. Okay, to check that problem, remember you write the original equation and we're going to substitute in the solution. We figured out that y equaled 3. So we are going to substitute the value of y into the original equation, which would mean 3.1 times 3 should equal 9.3 if we did everything right. In order to do that, I would ask you to go over to the side and do some multiplication. 3 1/10 times 3. 3 times 1 is 3. 3 times 3 is 9. We can see that there is one place value behind the decimal. So we should have a 1 in a circle up above our right-hand corner of our problem. And that means that we start at the end of our number and move it in one place. So we can see that 9 3/10 does equal 9 3/10, and we are correct. The next problem in your bell work, we had x minus 5/6 equals 7/8. What kind of problem this is will determine what we have to do. This problem is a subtraction problem, so we know we need to do the inverse operation on both sides of our equation. I've drawn a line down the middle of the equal sign because that's the middle of our equation. We know we want to get x all by itself. We want it in an isolation or solitary confinement. It's in a box. So we need to get rid of that 5/6. So we're going to do the inverse operation, which is addition on both sides of our equation. And we're going to add the 5/6 on both sides. When we add 5/6 and subtract 5/6, they equal Ohio State. So it will be left with x on this side. Then we have to do some fractions. We have 7/8 plus 5/6. In order to do fractions, you must find the least common multiple. We must find it. In this case, the least common multiple would be 24. What you do to one fraction, you do to the other, or the top to the bottom, the numerator to the denominator. So 6 to make an equivalent fraction with 24s. 6 is being multiplied by 4. What you do to the bottom, you must do to the top, so you will get 20/24 as the equivalent fraction to 5/6. 8 is being multiplied by 3 to make some 24s. What you do to the bottom or to the denominator, you must do to the top. So 7 times 3 is 21. Now you have like denominators, so you can add your fractions. When you add those fractions, you get 41 over 24. We all know that's an improper fraction because the numerator is bigger than the denominator. When the numerator is bigger than the denominator, you need to divide. To divide those, you push it over, and 41 becomes your dividend. 24 becomes your divisor. 24 goes into 41 one time, which equals 24 when you multiply. When we subtract, remember you must borrow. 11 minus 4 is 7. 3 minus 2 is 1. A quick note to put in your notes, guys. Remember, that is your whole number. That is your numerator, and that is your denominator. So in this case, x will equal 1 and 17/24. To check that problem, we need to take x, which equaled 1 and 17/24, and plug in that solution into our original equation. The original equation was x minus 5/6 equals 7/8. So now we can plug in the solution in for x. Now we have 1 and 17/24 minus 5/6 equals 7/8. We would write that vertically. Knowing this is a subtraction problem, we would find the least common multiple, which equals 24. 6 times 4 makes 24. So 5 times 4 equals 20. 24 times 1 is 24, so 17 times 1 is 17. But as you can see, we cannot subtract 20 from 17. So we need to borrow from the whole number, adding 24/24 to our problem. That's the one we borrowed. 24 plus 17. I'm going to have to move over here. 17 plus 24 would be our new numerator over 24 for our top fraction. That would equal 41 over 24 minus 20 over 24. When you subtract those two, you will get 21 over 24. When you reduce those by their greatest common factor, which is 3, you will get 7 over 8 and match what it's supposed to match. The next problem on our bell work was a minus -3 equals 7. And I know a lot of you probably got confused on this one, and that was for a good reason. This is a subtraction problem. We have the middle of our equation, and we know that the inverse operation of subtraction is to add on both sides. Remember, you want the a in isolation, so the inverse operation is to add. You're going to add -3 to both sides. You're going to add -3 to both sides. Tell me, what is the opposite of -3? Remembering that turns into +3. So you'll have +3 and -3, which will cancel each other out. See that? Then you're left with a equals, now you have 7 plus -3. Remember, you could do this with positive and negative symbols. You have 7 positives, and you're combining that with 3 negatives. You can make 0 pairs because you're combining them, and what you have left will be 4 positives. So your answer for this problem will be positive 4. To check it, you can go back to the original equation. A minus negative 3 equals 7. Plug in your solution for A. A equaled 4. 4 take away a negative 3 should equal 7. Well, if we do this with algebra tiles, you have positive 4, and we need to take away negative 3, but we don't have negative 3 to take away, so remember, you need to add 3 0 pairs in order to obtain the 3 negatives to take away. When you do that, you can cancel out your negatives or take those away, and you can count up that we would have 7 positives left.